That's pretty good. That is pretty good.
That might be the best title yet.
Hello and welcome to the Hackaday Podcast. I'm Elliot Williams.
And I'm Tom Nardi.
This is episode 334, Radioactive Shrimp Clocks, Funky Filaments, and Owning the Hardware. This week in Hackaday News, the funniest thing happened. We wrote up a piece, Food Irradiation is Not as Bad as It Sounds, which is all about sterilizing food by hitting it with a bunch of gamma rays. Does not make the food radioactive at all. Does heat it up a little and maybe denature some vitamins. You know, you can read the article if you want to dig into it. The very same day, there was a radioactive shrimp crisis in America.
Attack of the radioactive shrimp.
And these two are completely unrelated, but we had Lewin's article queued up, I think, last Thursday, and could not have foreseen Walmart shrimp may have been exposed to radioactive material. Apparently, they got shipments of shrimp that were contaminated with cesium-137, and we'll be talking more radioactivity pretty soon, so keep your cesium sensors open. But do note that irradiating food, you keep the radioactive source outside of the food so it doesn't contaminate the food. What the heck were they doing with cesium in the same shipping container as frozen shrimp?
Yeah, right. I read a couple different articles and nobody ever was able to satisfactorily explain that part of it. But the last thing I saw was that the FDA, they said they didn't believe any of the shrimp were contaminated, but you should probably just throw it away because it definitely, got here in a contaminated container, and that's reason enough to throw away a bag of shrimp that you paid, $5 for.
Fair enough. Great value brand frozen shrimp.
Well, that's the value,
Values the extra cesium.
Yeah, right.
Yeah, they tested some packages and said that they didn't detect any that were above the intervention level of 1,200 becquerels per kilogram. And a becquerel is one radioactive event per second. Again, hold that thought. So 1,200 decay products per second per kilogram apparently is the intervention level, and these were below that. On the other hand, if you're eating the shrimp, that radioactivity is going off inside you. I'm not with a 10-foot pole.
I did read too that they said the FDA has banned that company from importing anything until they can figure out what happened and show, I guess, that it'll never happen again. Which, I guess that's pretty harsh, but I think probably fair.
Fair enough. Absolutely.
If you're importing radioactive food, I think, probably a closet, a blanket ban on everything you have coming in until we figure that out is probably for the best.
Have to sit on the naughty step until you can clear that up. Anyway, two totally unrelated radioactive news stories, but stick tight. Wait for the hacks. We've got radioactive hacks coming up. But before we do that, we have to talk about what's that sound?
This is a journey into sound.
What's that sound?
What's that sound?
This week is a reveal week. So, Tom, you get to listen to it, and we'll see who among the correct answers is in the running for a Hackaday Podcast t-shirt.
Oh, okay. Wow. A wooden bouncy thing with a bell. I'll call it art. How about that? Is it a mechanical art installation of some type?
I like that. It's not bad. What does it sound like is happening?
I mean, it sounds like someone's using a stool as a pogo stick. and hitting a bell on the ceiling once in a while, but that's probably just my imagination run wild.
That's pretty good. Yeah, Christina had a coin sorter machine, which I could totally hear in there.
Okay, yeah, more likely than my guess.
I don't actually know what a pogo stick on a stool sounds like, but or whatever the heck.
That's next week's sound. We'll compare.
Some really good guesses were a Winter Gatan marble machine. I thought that was pretty solid.
Oh, yeah. You know what? I think that's a way better guess. I want that. Retroactively, I've taken that guess.
How about bolts washer nuts counting machine, hardware sorting machine? A couple of these came up. Those are also not correct. The correct answer is a Japanese pachinko machine. In particular, this is a pretty old one. It's a vintage pachinko machine. Patrick actually found the YouTube video in question. It's kind of like a pinball machine. You shoot up balls and then they bounce off a bunch of nails and kind of a
on
random
the way
pattern.
down.
And when they get caught by the hippopotamus or whatever, then you get extra balls out in the bottom. And that's that kind of clinkety clink sound. You could play for hours. And it's just like shoot balls, shoot balls, shoot balls. It's a moderately addictive gambling. Anyway, 10 people got it right. So congratulations. We had... this was a tough one. We had 23 people answered. 23 answers, 10 got it right. You haven't seen the spreadsheet, have you?
No.
Pick a random number from 1 to 10.
6.
Congratulations to Gesundheit, whose answer is simply Pachinko. Congrats. We'll be getting you a Hackaday Podcast t-shirt. Thanks, Tom, for picking a random number.
I do my best.
I really need to collect all the wrong answers, and we need to use those sometime.
Like, seek those ones out, right?
Pogo stick. What was it you said?
Someone using a wooden stool as a pogo stick.
Wooden stool as a pogo stick.
I'll see what I can do. I'll try to get you a recording, and or I'll end up in the hospital.
Sounds good.
Should be exciting either way.
Well, congratulations again, Gesundheit, and the rest of you. Stick around next week. We'll come in with a brand new sound if Tom's not in the hospital.
Yeah.
All right, then here we go off to the hacks. My first one, I just lumped a whole bunch of really cool One Hertz challenge projects together because the One Hertz challenge ended a couple days ago. I am sending the scoring sheets out to our judges very shortly, and then we'll get the winners out probably next week sometime. Just been amazing entries in this.
Oh, yeah.
And I'm not judging it, so I feel free to pick a couple of my favorites here.
I'll be sad to see this contest go, honestly. We've seen so many incredible, and like every day there's been
This
one or two we've been able to run.
Has kept on giving. I actually, over on Mastodon, someone was like, I have this really great project, and was showing off a mechanical clock build, basically, and was like, I should enter this in the One Hertz challenge. And I'm like, go do it. You have 6 hours left. And I think he did. Anyway, the first two I have share a common theme, and that theme is atomic decay used as the timekeeping source. Unfortunately, neither of them use dodgy shrimp. Both of them use proper radioactive sources. I really liked Alan Wilson with none of the vowels. A 1 Hertz challenge atomic clock decay clock is accurate but not precise. The short story here is he takes a rock sample that probably has some uranium and thorium and who knows what else in it, but, a hot rock sample, and builds a Geiger counter circuit and a diode radiation detector circuit, points them both at it, also sets up a real-time clock, also sets up an Arduino just running milliseconds, and then he lets them run. And this is a long-running experiment. He actually ran it for a year from March to March last year. It does drive a real clock, which is cool. It aggregates up enough clicks on the Geiger counter, and then it advances a second, and then it aggregates up enough clicks again, and then it goes another second. And I think, what did he end up using in the end? Something like just about 78 clicks per second was what he decided worked for his. And so he timed it out first, and then he let him run. He's got this year-long time series data on this, and it's really interesting. The diode one is just horrible. It deviates by like an hour before the year's over. As a clock source, it's just like totally out of the running. The Geiger counter tube is awesome. It works really well. It's still way out in the middle of the year, but it gets back around. And so he makes a plot of this with temperature and discovers that it's pretty sensitive. The two of them basically follow the same hump-shaped curve. So he's pretty sure that something due to temperature is going on there. And I don't think the radioactive decay increases so quickly with temperature. So maybe it's the Geiger counter is more sensitive? Question mark? I still don't know what's going on there. But he finds that both the real-time clock and the Arduino's milliseconds are pretty darn good over the year's time span. And they both drift, but they both have this really nice linear drift that seems to be mostly immune to temperature. Anyway, really cool. The fun thing about this, of course, is that the individual decay events are random and independent of each other. So the seconds are all wrong each individually, but they kind of average out to be right. And that's what's really fun about this clock, is that the second hand does not tick every second, but it does pretty well in aggregate. He also uses the arrival times of the decays to feed a random number generator. So he's got both a random number generator and a clock out of the same circuit. Love that. If you want to go look into other crazy projects where people have used radiation to make a time source, there's actually a storied history of this. I'll be talking more about some of those soon, actually, because the history of these gets really, really interesting. But before I do that, I want to talk about the other atomic clock, which is Mihai Cujicic's One Hertz challenge timekeeping at 1 becquerel. Mihai is the creator of the Pomelo, a really nice gamma ray spectrometer that he's built himself. It's got a small scintillation cube. When it gets hit by a radioactive particle, it actually lights up. And then behind that, he's got a solid state photodetector that says, "I see a light flash." And by the intensity of the light flash, it's able to tell how much energy whatever the radioactive source had. And so you can actually use this to figure out what kind of radioactive source you're looking at from the distribution of these things. Gamma ray spectrometry. Here he's got an americium sample and he puts it near it. He uses two of these. One has the americium sample inside it, so it can get the alpha particles off of it, and the other's off to the side and shielded from it, but can still get the gamma rays. And so when americium decays, you get an alpha and a gamma out at basically the same time. And here he's kind of nulling out the background radiation by only taking account when he gets both an alpha and a gamma at the same time. So he can be pretty sure it came from his source. A cool radioactivity trick. But even crazier, he calls this one the 1 becquerel detector, which means he tries to tune it by moving the source further away from one of the detectors to tune it to give off, on average, 1 radioactive decay element per second. So it has an intensity at that distance of exactly 1 becquerel. And this one, because it uses such a low radioactive decay event count per second, unlike Alan's, is completely random looking seconds. They are like tick, 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 tick. It's just entirely random, but also works out over the long run. And I think that's fantastic. It ends up being less accurate than Alan's, but you know, who cares? He is using a pair of homemade scintillation detectors for this clock. So that's just awesome.
Well, I like how this one, it loses, like less than half a second a day. And in the comments, it says that's actually like corresponds with the decay rate of the sample.
Right.
So it's not like the clock is actually losing the accuracy. Everything is working as intended. It's just the radioactivity of the sample falling off a little bit more every day, I guess.
It's fun too because Alan and Mihai are in each other's comments on the Hackaday IO projects, cheering each other on, but also saying, "Oh, I like the way you did this." And that's one of the things that Alan's project doesn't have this problem with. He mentions that, his sample is a rock, right? And so it's
Much
billions of
longer
years old.
Yeah.
And so he's probably not going to notice the decay products in his life, whereas americium decays pretty short, like 100-year half-life or something. I don't know. I made that up, but it's like human timescale half-life. So it could be slowing down, actually.
Right. Yeah, enough that you notice a little bit every day instead of every decade.
I'm throwing the links from Alan's projects into the show notes here because they're so fantastic. There's a history of these kind of clocks going way back. There was one in the 50s that apparently they did with cesium, of all things, in the Chase Manhattan Bank. A number of people, both Alan and another, looked for more details on this and couldn't find it. That's unfortunate. The Gamma Clock, another clock project on Hackaday IO, is worth looking at if you're into this sort of thing. And finally, there was the craziest atomic decay clock ever, buried in the time capsule for the 1970 Japanese World Fair. And I will put links to this in there because that time capsule by itself is the most amazing thing. I think maybe we have to write this one up for Hackaday. It's so crazy. But the clock worked like this. It had a gram of plutonium in it, and it decays by making alpha particles, which are basically helium nuclei. It was in a sealed container, but with a bellows. And so it would give off more and more single helium atoms that would then turn into helium and would slowly expand. And so this expansion would turn the dial. So it's an entirely mechanical radioactivity-driven clock, but one that's supposed to tell time over the 5,000-year time scale that this time capsule is meant to be reopened. Like, it's meant to be reopened in 6,970. Good luck with that.
Yeah, really. Can we start with like 1,000-year time capsule and work our way up to the 5,000?
So they actually buried two of them. One of them's supposed to be opened every 100 years and updated.
Good.
So that the one that's to be opened in 5,000 years is still relevant by the time it gets opened. And actually, they thought about this and they thought, 1,000 years isn't really that long. If we put some artifacts of today's civilization in there, some of them will probably still be around in 1,000 years. So they thought, let's really push the envelope here. Let's put things in here that guaranteed won't still be around. So it's got like a first generation Walkman. It's got like an artificial eye, like a prosthetic eye. It's got, it's the craziest collection of things. Again, we have to write this up for Hackaday. But it's also got this clock that works on radioactive decay that's meant to run for 5,000 years. So, yeah. And if all of that wasn't crazy enough, I have one more bonus clock I have to throw in. No radioactivity here. Deriving 1 Hertz from candle flame oscillations. And this is from Tim alias CPLD CPU. Love his stuff. He's been investigating candle flames to make cool looking LED displays for the past decade, 15 years? I don't even know how long. Everything I know about candle flame flicker physics I learned from him. This one uses a trick where if you put two candles next to each other, I guess he's using 3 in the clock, the draft coming off of one blows the other one and they get into this stable oscillating pattern that is just dependent on the diameter of the candles and gravity. And so he figures, well, this is a good enough thing to use as a time base because gravity doesn't change. So he times these things out and they flicker at 9.9 hertz. And so he wants to use this as a time base for his blinking LED, of course. First thought is to use a phototransistor, but that's lame. Second thought is to wrap the candles with a wire and then suspend another wire in the flame. Use the capacitance between these two, which varies depending on how much flame there is in the circuit, as the flame detector. And that's what he ends up doing. Today, I learned that you can detect candle flicker by putting a wire in the candle and wrapping another around the bottom of it. Anyway, all three of these are wild clocks. I really have a soft spot for the radioactive decay ones because they take something that is knowably quantumly random, but averages out over the long term, and they make clocks out of it. I think that's just sweet. And Tim's, I liked yours because it uses a physical phenomenon I had no idea existed until seeing it used to blink an LED.
True of so many physical phenomena, right? We don't notice it until somebody's blinking LEDs with it. Well, my first pick this week is Suggested Schematic Standards. Let's say that 3 times quick. This one comes from Graham Sutherland, and it's a nice write-up that just sort of goes over some best practices when you're making, digital schematic. You could argue, I suppose, that a lot of this is just aesthetics, right? Because, he'll show an example and say, okay, well, here's another way you could do it. And it looks better. The original wasn't wrong. They're both valid and will work. But, when you're talking about something that you hope to share with a community and you want others to be able to understand and maybe improve, there's a case to be made that you should try to make things as easy to read as possible. If you're doing it on your own. I suppose nobody can stop you from doing the schematic however you like, but I can say, looking at a lot of these side-by-side examples that are given here, I tend to go with Graham on most of them. And, a lot of them are very simple. The first one is like, don't have weird kinks in your wires if you don't need to. Like, just align your components with, if possible, align your components with the pins on whatever you're connecting it to, so everything is like nice straight lines. A simple thing like that shifts things over a couple pixels and it'll line up a lot nicer. Other things, ground should always be on the bottom. You should have kind of a horizontal left or right logical layout. I like to think I'm doing most of these already, but it's good to see somebody actually explain it all and say why it's better and show a counter example as to why it's superior. Avoiding diagonal lines, stuff like that. One part that, and I might be on the wrong side of history here. Well, so I'm curious to see what Elliot thinks. After it goes through all the minor stuff, which is it is minor. It is, like I said, it's make sure things align, make sure you're not taking weird angles if you don't need to. Then it gets more into the logic of putting your schematic together and in using like net labels to connect things versus wires, and then following that you break everything down into little blocks, and you have functional blocks that are on the schematic that are linked with net labels. And I get that, and I see a lot of that now being used, but I do find it, if you're looking at just a PDF of it, it's a lot harder to parse that because you don't have the luxury of being able to, click a label and seeing where the other end shows up. So I do think that stuff like that works best in a fully digital environment. And maybe that's fine, right? Because I guess 99% of people will probably be looking at it in the editor. But there has been times where I've been, looking at a printout on paper, no less, of a schematic and trying to figure out, like, okay, well, here's a net label on the top left of the page, and here's 100 places it could be, and I gotta hunt and peck for it. But and then it goes into another thing that I see kind of both sides of, and that's whether your symbols should physically look like the part they are standing in for. And I don't know, I kind of see that both ways. He makes the case that like the pins should be aligned logically, so that all your analogs pins are in this little group, all the digital pins are here, the power ones are on the top, yada yada. Whereas a lot of vendor supplied symbols will look exactly like the physical pin count, come what may. Personally, I like the idea that the symbol looks like the real part. It helps me kind of figure out where everything's going to go, but it is definitely harder to make a nice, clean schematic when, your pins could be all over the place and not grouped in the ways you're actually going to use them.
This one does start off with the easy stuff that we can kind of all agree on, and then gets into the tricky ones. I mean, whether you draw the lines or whether you do the labels, whether you label nets and then have them go somewhere else. I hear you. If you're just looking at a PDF of it, it's impossible to find where that other
right.
net is.
It very quickly becomes
spending some time looking for it. It becomes a hassle. And, we do see lines and we see patterns and we see connections. We're pattern matching machines, right? This is something we're good at. So you should use that rather than make us like do a word search for the SCK symbol somewhere on the thing. And I agree with that. On the other hand, sometimes that ends up with like hundreds of lines just everywhere, and that becomes messy too. And so one of the suggestions is to replace the myriad lines with one line by doing a bus, or put the parts close enough together that the lines don't have to go far, so it's really easy and obvious. A trick I always use is so if you have a microcontroller and a radio module, you label the lines going to the radio module radio underscore SCK, radio underscore SDA, whatever, right? So you know by looking at the label where it's going to end up.
Right. At least a general area. Yeah.
You don't need to go look at the other end because you know it's going to go to the SDA pin on the radio, right? Like, why would I even bother looking for it? So that kind of helps too. Mentions this also in the write-up of splitting bigger schematics up into smaller labeled blocks. I actually really like the hierarchical sheets that KiCad lets you do, where you can kind of define a second sheet of the schematic as if it were a component. So you can put a couple pins that you want to expose to the upper level schematic on there, and then, basically just hide it away, but then that sheet shows up as a component, air quotes, with those exposed pins on it. So like if you have a power subsystem, you just have a sheet labeled power, and then you expose plus 3 volts ground, maybe whatever else to the rest of the circuit where you care about the logic. And then you can keep the battery and the charging circuitry and the voltage conversion stuff all in the same power sheet, and you don't have to expose those to the rest because logically they don't interact with the rest of the design most of the time. They're just there to, provide you your voltage levels. That kind of separation is really nice, and he suggests doing that. And then that makes using those net names easier, but it also makes drawing the circuits easier. And so there's 2 goals of a schematic these days. And one of them is you need to do this to get your PCB made, right? I want to get the footprints laid out. And so I need to draw the schematic to get the parts in there so that I can lay them out. But then the broader goal is, like you just said, sharing it with the community. And that puts a different constraint on what you're doing with the schematic. You want to make the schematic something that is readable for people who want to come after you and modify it or add on to it or figure out what's wrong with their board. And those aren't even always the same goals. And so you really... It's like writing anything. You have to know your audience and think about what they're going to want from your schematic when you're doing it if you want to be a really nice person.
I suppose I kind of think of it from a repair standpoint.
Yeah.
I guess less and less anymore, but it used to be, an appliance would come with, a printed schematic inside the cabinet somewhere, right? And you imagine if you opened that thing up and there was a bunch of labels. You're looking at this, like, trying to figure out how the washing machine works, and it's just all these little labels that you have to connect yourself, like a connect the dot puzzle. So it is the difference between, like you said, some of these schematics are made just as I'd almost say like a necessary evil, right? Because you do need to do it just to make everything work electrically so you can get to the fun part, which is placing all the things and getting your board made. I wonder if there's, a place for both kind of, like, surely there must be some kind of script that could be written that would, connect the net labels and stuff for you if your intent was to print out a copy. But yeah, therein lies a rat's nest, right? So
yeah.
I guess you would need to approach it from scratch with the idea of, like, I want this to be one big cohesive schematic that can be readable later. Or I need to get this done so I can make circuit boards. So I can see both. I've been in both cases, and I can't fault you either way. I think probably the most important thing is that at least you made the schematic and gave it out, right, so that we have something to work with.
Yeah, and your repair case is a third one. So there's like, I slapped it together. I want this as documentation, and then I want this to be a repair guide. And that's where the hot debate, if there's one I think that's still left, it's when you have a symbol for a microcontroller or an IC. Do you put the pins in 1, 2, 3, 4, 5 order, or do you put them in logical order? And like you said, do you put the analog things together? Do you put the functional groups together? Or do you lay it out by pin numbers? And if you're trying to troubleshoot a physical device, having it laid out by pin numbers is totally helpful. And so if the people reading your schematic are, if it's a soldering kit for newbies, and it's very likely that they will be using this schematic to troubleshoot things, then A, it's super nice to do it with pin number ordering, but B, also add notes to your schematic where you're like, it should be 5 volts at this joint, or you should see a square wave at this joint. Add test points and, write that down in the schematic. You could do a lot to help people troubleshoot things in a schematic. Again, it's somehow you have to know your audience and anticipate what they want and do the
Yeah.
right
Well,
thing by them.
are they fixing it or are they building it? Is probably the the core breakdown.
Well, my next hacks are a twofer of funny 3D printing filaments. The first one is from Lost in Tech, and I love his videos on 3D printing. He's got a really nice macro camera and he's not afraid to use it. Here he's got a cross polarization setup to show stress in the resulting print. Sweet, sweet. This is like, I don't always love videos. I sometimes like my information in the form of the printed word, but this is a good video because it makes use of the video medium. Should you try printing with polypropylene? Well, the answer is yeah, you probably should. And he goes through what the upsides and downsides of polypropylene filament are. In the last few months, polypropylene filament has gotten a lot cheaper. A couple of the big manufacturers are making it now, and prices are sinking. The first thing he notices is that the stuff does not stick to basically any normal print bed, but polypropylene sticks marvelously to itself. And regular transparent packing tape is polypropylene. So you can just put down some packing tape on your bed and print straight on that. It sticks very well. So well, of course, that it peels the tape up, which means you have to put down a new layer of tape every time, and that's lame. He ends up getting a polypropylene printing surface, I think from Prusa. So it's a Prusa polypropylene printing surface. I did it. I pulled that off. And it needs a little bit of heat, but not too much. Nothing super strange in printing. It really likes to warp. It has more shrinkage than most of the materials you're used to working with, unless you've been doing a lot of ABS printing. And that's one of the things to worry about, both in terms of dimensions of the things you're printing and tendency to warp and draw together as it cools. But other than that, it is basically easy to print. It doesn't smell. It's not particularly toxic, or at least certainly not worse for you when you're printing it than PLA is. It looks good. It's a little bit flexible, but not super bendy like the TPUs are. If you think about polypropylene, it's like plastic lids or something. It's a strong, tough, but also flexible material if you print it thin. And that's what's really neat about it. And that's kind of its superpower that it brings to your 3D printing kit. Yeah, watching the video, it makes me think I have 2 or 3 applications. So I might have to pick up a reel.
I look at these and I feel like I'm still so basic. I'm just doing PLA and PETG. More PETG, honestly, now. I really don't use PLA unless it's something I don't want to say don't care about, but it's just definitely anything functional is PETG, and PLA I sometimes do for like a prototype. I mean, just because it's the temperature's lower, so it takes less time to heat up and cool back down, so you can kind of iterate quicker through it. But yeah, like you said, it does seem like there's been kind of this explosion of newer filaments, which probably has something to do with the availability of better 3D printers, too, I'd imagine, as more capable machines have dropped in price and, suddenly people aren't wrestling with their hack-together Ender 3s and it can actually print engineering plastics and stuff. The demand is there finally, which is, I guess, good for all of us. I haven't personally played around with any of this stuff, but like I said, it makes a case. Right, I can certainly see some applications for it. We've said it before, but I mean, the more tools at the disposal of the community, the better. Right, even if it's not something that you personally are into, just the fact that this stuff is now becoming available and affordable, we're going to see new ideas and new projects that we didn't see before because the tech just wasn't there. So anytime something like this comes out or becomes mainstream, even if mainstream is perhaps mainstream for us, right? Not mainstream for the normies, but at least mainstream in the making and hacking community. I get very excited because I know more stuff's coming down the pike after it,
Yeah, and I think the preview on polypropylene is that when it's thin, it's very flexible. So this makes all the living hinges much more usable than, for instance, with PLA, which ends up being too brittle to do living hinges over the long run. So I think I think we're going to see that a bunch. The other funny filament I wanted to talk about was Morflex, the TPU filament that goes soft after you print it. This is a review of that particular filament by Modbot, but this is just one of the kind of family of foaming TPU filaments out there. They've got an additive, and I think it's sodium bicarbonate in it. I think it rises like your muffins rise, basically. And the hotter you print it, the more air gets entrapped. You could kind of control how foamy the filament is. The gimmick here is that, at least with the Morflex stuff, it's a kind of hard rubbery filament when it's solid, but then because it gets inflated with air as it goes out the nozzle, it gets softer and softer. And so they advertise, 95A shore hardness coming in and between 70 and 80 going out. And I've seen people push other foaming TPUs even down into like 40A shore hardness, which is like really, really squishy. What is 40A? It's like marshmallow squishy almost. It's like really squishy. Anyway, I also haven't played around with foaming TPUs. I've just gotten to be doing TPU lately, much less playing around with the foaming ones. There's also foaming PLA these days, which has been making the rounds in the printing airplane models scene because it ends up being a lot lighter because, it's half air. Foaming TPUs are awesome because you can make a really soft rubbery thing. So if you want like shoe soles or something, or, just anything that's squishy like a marshmallow, you can get that consistency out. Foaming PLAs are great because they're rigid like PLA but half the weight, and so they're good for making airframes or whatever else needs to be really light. The new crops of foaming filaments are also super interesting and worth looking into. The one caveat with the TPU ones is even though they are stiffer before printing, they're still not stiff enough that you want to use any of the printers with the Bowden tubes. Morflex claims that theirs is harder than most of the other foaming TPUs beforehand, and that you can probably feed it into, something like a bamboo as long as you don't use the automatic feeder. They actually have a TPU feeder path. But you've still got that Bowden tube in there, and it still is going to want to flex and compress in the Bowden tube on the way out, and that's a recipe for disaster. So that's where direct drive nozzles still, after all these years, your bed slingers revolt, right? The bed slingers are still kicking it when it comes to flexible filaments, as far as I'm concerned.
If no one listening has ever had the experience of trying to print TPU, it might be lost why this is, such a good idea, is because it is such a, even with a direct drive, I've done a little bit of TPU, and admittedly it was a while ago, and, things are always improving, but, even with a direct drive, I would have, the stuff would wrap itself around the extruder gear, and it's like, imagine trying to get a wet noodle to obey any command. It's very tricky to deal with. So the idea that you could have something that's at least less wiggly and then get soft afterwards is a huge, huge deal. But like you're saying, even still, I would not do it with a Bowden. I really dislike the whole, getting off the topic here, but I understand the necessity for, moving the extruder motor off the hot end to try to get the weight down and everything. But I just feel like the trade-offs are, unless you're really, really, really going to go fast for whatever reason, I always prefer a direct drive.
If pushing PLA is like pushing uncooked spaghetti, 95 hardness TPU is like pushing al dente spaghetti. And then some of the stuff that's like even softer, it just limits how soft a final object you can print. And so it's nice to have these kind of other things that are either flexible or squishy in our arsenal to print with. And that's kind of why I wanted to feature these. And just, if you are out there printing with soft, flexible, or otherwise filaments, let us know what the new hotness is. We'd love to cover it.
Dealing with flexible is enough of a hassle that a couple times where I needed something soft, I would do the very suspect hack of, printing it in PLA and then submerging it in brake fluid, brake cleaner. Have you ever done that?
No.
It does work. I mean, having enough brake cleaner that it's in its liquid form is sketchy in itself. But if you put PLA in liquid brake cleaner, something happens to it very quickly, and it comes out rubbery. So if you had to like do a gasket or something.
When it dries, does it get hard again, or does it stay rubbery?
No, it stays. Whatever it does to it, it breaks something down. That it still seems relatively strong and intact, but it becomes flexible and rubbery.
Oh, how cool is that?
Yeah, I've done it a couple times, like when I need like to do a gasket or something that's like an exact size. Like you just print it in PLA and dunk it, and then it gets at least squishy enough to work for that.
Ah, cool. I've used the hot air gun to like partially melt things and then form them. My son had he 3D printed some dragons that he wanted to put on this hilt from a katana that he'd made. Kids these days. And he's like, "Here, can you help me bend these?" And so we come up here and we're hot air gunning the thing till it melts, and then right around there, beautiful fit. But no, but of course that dries solid again. So that's not like your brake cleaner trick.
All kinds of tricks today.
Tell you what,
you're learning something on this episode. Well, my next one is from smartphone to a home server. And I know we've talked about this a lot, but I think because it's important, the reality is most of us are carrying computers in our pockets, and we might not use them that way when they're the new hotness. Strangely enough, we're talking to people on them because they're phones and sending messages and maybe using a couple apps, but every couple years or longer, that phone gets replaced, and more often than not, it just sits in a drawer somewhere, and it's a real shame because it has everything you need to be a computer. It's got the memory and storage and processing power that would have made a desktop blush a couple decades back, and it all happens to have a built-in battery backup too, in addition to the sensors and everything. I mean, it's really, if you told somebody 20 years ago that these are things that we would just throw in a drawer and not do anything with them, they'd think you're crazy. Like, what do you mean you're wasting these things? Like, you don't have anything you can do with them? So this is a video from Hardware Haven that puts forth the idea of using them for basically just a home automation kind of little server. In this case, it kind of explains the two main approaches to using a phone as not a phone, and sort of like the state of the art for both of them. Because, Android is Linux with some caveats, right? It is more or less Linux, but it's different enough that you can't just use it that way, right? So there are projects that you can pop open a terminal on the phone, and it gives you a virtual Linux environment that's good enough for most stuff. But then there's also, in this case, he's using Post-Market OS, which is designed to be like a native Linux for the phone, right? So depending on what your needs are, like if you just want to, run a Python script or something on there, that you could probably do that with the firmware that's already on your phone, with the addition of like a terminal app. But if you really want to, do something that it involves the hardware a lot more, or, some of these things you could even run like graphical apps on them, then you're probably going to need to switch to more like a native Linux approach. And in addition, to make things even more complicated, there's talk that Google is looking to add a native terminal app to Android going forward. I think if you get like the Android unstable channel or whatever, and you download the alpha builds, there actually is a terminal app that would ship with the device, which has some really interesting possibilities if now every Android device actually has a terminal, from the factory, and what that means. But we'll have to, we'll cross that bridge when we get there. I think that'd be really cool, and kind of speaks towards their idea of eventually making, one OS for Chrome devices and Android, but that's a whole other thing. In any event, I welcome the addition of an actual native terminal app in Android. But until then, this video kind of goes over what your options are, and which one makes the most sense depending on what you're trying to get done.
What I really liked about this project is that he started in what I think of as entirely backwards, which is he started with, I'm going to run Post-Market OS on this what's the right cheap used phone to get on eBay that'll be maximally easy to run post market on. And I think that's pretty cool. Like if you are just looking for a, small, quick and dirty home server sort of thing like he's doing here, that's the right way to approach it. And you can find used phones for $20, $30, no problem, that run post market OS really well if that's what you're into. And I think that's pretty cool. He went through the whole replacing the battery thing, which, man, fooling the battery charging circuitry into thinking that it's got a loaded battery in it without wanting to charge it is its own project. There's some real hardware work on that side, but I think the basic project's really cool. And like you say, it may be getting easier in the future. A whole bunch of people say Termux, which is a terminal on Android, make it kind of quasi Linux-like. But then you still have got all the other stuff that comes with your phone's initial operating system that you may or may not want to disable depending on how much your power budget is and stuff like that. So I totally see this approach of just, buy the phone that runs with the operating system, nuke everything on it, put the operating system on it. You've got a known quantity. You kind of know you're good to go. I don't think it makes it easy, but I think that's the path of least resistance.
Well, and still, you're probably keeping something out of a landfill, right? Because you're talking about, when you're saying you're getting a phone for $20, $30, obviously these are used phones, right? So it's still a net positive, even if it's not your own used phone. It's somebody's used phone, and it's one less device just sitting there lingering. You mentioned about the battery part, and that's kind of interesting because we come back around to this once in a while about like what would make phones and tablets and whatever, what would make them more useful, or maybe not useful, but more approachable for general hacking. And we've talked about, it'd be cool if they had like breakouts for I2C and so, and that's realistically probably not going to happen. But I think the battery thing is probably something that could be addressed manufacturer. Like, why do these things not want to run without a battery? You know what I mean? Like, why do they make them that way? And would it really be such a big deal for them to just have that be like an option in the bootloader or something? Like, let me boot this stupid phone with no battery in it. That would be a simple thing they could do during the design phase that I think would probably open up a lot of possibilities for these devices having a second life as a experimental whatever platform versus I don't want to leave it plugged in because the battery is gonna poof up on me or the battery's stone dead and it won't start anyway. You know what I mean?
Yeah. Or you need the USB to hook up to a network card or to something else anyway.
Yeah, so some kind of alternate power path would be really cool for phones, and I'm sure we won't get that either because they don't care. They're just making them to sell them, and they want to sell you next year's. But I mean, the ability to just say, okay, forget about the battery, and even better, here's two pads where I've provided 5 volts. That would be awesome, but we can dream.
I don't think you have to be too cynical to suggest that Apple sells more phones by having the phone be a brick once the battery's dead. I think the non-replaceable battery is a feature if you're trying to sell more phones.
But I do wonder, like, why can't I? And it is almost universal. Like, why can't I start a phone without a battery in it? Like, they must have made that decision at some point intentionally. Say to sell phones, just so that, like, if the battery fails, well, gotta get a new phone. Like, could they really be that devious? Yeah, I guess they could. Now that I said it out loud, I suppose. Because I don't think I've ever seen a smartphone that you could take the battery out and it would start. It always just says, oh, no, there's no battery. I can't,
no battery. Even if it's plugged into USB, it's not going to
start. Right, exactly. I'm not expecting moonbeams to power.
Thank you.
Like no battery. It's plugged in and it just says, no, can't start, can't do it, won't do it. It just, I don't get it. Like, it seems like something they must have done intentionally, but all the manufacturers have agreed to it. I'd love to, if anybody knows, if there is some legitimate reason why these things are designed so that they won't start without a battery present, I'd love to hear about it.
All right, bringing up the rear for me, a solderless soluble circuit board by Ziyu Yan and all at University of Maryland. This is a project from a lab there that's been working on making prototyping more reusable and environmentally friendly. And we've seen a couple projects from them before. One where they made a program to kind of automatically do bodge wires for you and reconfigure a circuit board from a bad state to a good state, by
Oh yeah.
and it used like a PCB board router and stuff, and it was integrated in with the flow. I really liked that idea. Of course, I don't make mistakes in my PCBs, so I wouldn't ever use this tool, but I have heard other people do. Another one they had was a solderless breadboard, which had the components pressed together by two custom 3D printed plastic holders. And so nothing was soldered at all. It was just held together in place. And that one, again, leveraged the kind of open source EDA tool flow to combine circuit making with making these custom 3D prints to hold it together. And that's also what's going on with this one. And they've upped their recyclability game by making the PCB quote substrate out of PVA so it can dissolve in water and even potentially be reclaimed. But I think that's pushing it too far. We'll talk about that in a minute. They make the tracks out of a eutectic indium gallium alloy that they then inject into channels in the 3D printed form and then plug the components into those. And so basically you put the thing in water, the PVA dissolves, the gallium indium dissolves, and you've got your components back out, and everything is entirely reusable. And it's a wild idea, but they've got it working and in a prototype. And again, it's partly due to this really clever FreeCAD plugin that they made that works with KiCad. So you design the circuit, and then they have a plugin that turns it into this 3D print with the channels in it for you to inject the liquid metal into. Like their other projects, this isn't just a one-off hard to do flow. They've got a whole tooling flow to make doing this useful. And again, it's early days on all of this, and the parts are big and etc. But it's just such a really cool procedure, and they've made it kind of so approachable by using open source tools and automating the hard parts that I think it's really, really cool and worth looking at. If you scroll down in the end to the bottom of their applications page, though, they get to the parts that I think are really cool, which is taking these out of the flat PCB realm and into kind of 3D objects. And so they've got an example of a fidget toy / joystick kind of thing, which is in a 3D printed form by itself, but the quote wires, which are this liquid metal, flow through it as well. And so it's a 3D circuit embedded within a 3D print, and all of it functional, and then of course completely recyclable. And that really makes me think that this would be fun for a kind of rapid iteration, rapid prototyping, where you can both prototype the physical object and an integrated circuit, like literally integrated into it. There's some neat and wild new possibilities here. And a bunch of people had some questions about where the limits of this were, and Shuan Hong, who's on the team, comes into the comments and answers all the questions. So if you think this is a cool technique, you should definitely check it out, add your comments to it, and you'll get your comments read by the paper's author.
I know, obviously, the dissolvability and the recyclability is a big part of this particular approach. When I look at this, I can't help but thinking it's all kind of a symptom of something we've always been struggling with, and that it's harder than it should be to make prototype boards. How many machines have we seen that to crank out a PCB at home? Whether it's etching it or lasering it or whatever. We've seen like the 3D printed ones where you got to like stick the physical wires in. We've seen people do boards that way, and then this is kind of evolution of that, where there's no physical wire. It's it's a conductive liquid, but it all kind of stems from the fact that like people want to make prototypes. They don't want to do the breadboard, and there needs to be something. There needs to be some kind of intermediary between here's some crap on a breadboard, but I don't necessarily want or need, or I'm not ready to send away for a stack of 10 circuit boards. And even I would lump like jumperless into that too, which I think probably jumperless is probably the best approach, although by its nature it's expensive, right? Because all the the switching stuff that has to happen in the breadboard. But that's probably the closest we've got so far to a way to prototype this stuff quickly and in a reusable way, right? Because like in the same way that you could melt this thing down in theory, you could just reconfigure jumperless for something else. It's not like making a circuit board and you're stuck with it. I don't know. I don't know what the solution is. We've certainly seen many attempts at it for like truly rapid prototyping. Someone's going to get it right. I don't know that this is necessarily it for the average hobbyist. I do like that there's still stones left unturned, right, for making quick, not even boards at this point, but quick prototype circuits. Leveraging the 3D printers that a lot of makers have is probably the right approach too, if you're going to do it. Keep searching, right? Like,
right.
I think we should keep searching until we find whatever this mythical, rapid, easy to use, non-toxic. It's a very tricky problem. All right, well, this last one I picked, certainly not because I'm listening to CDs. I couldn't tell you the last time I picked up a physical CD, but I had heard about this story, so it was cool to see someone look into it and give it a proper investigation, right? This one is why Lorde's clear CD has so many playback issues. And if you haven't heard about this, the artist Lorde put out a CD that is completely clear. The album name is Virgin, and I suppose there's some imagery there that we're supposed to see through it or whatever. And it is interesting to note that the disc doesn't have like the proper compact CD Red Book compliance label on it. So like it seems like they knew this was kind of a hack when they made the thing, but once it got out in the wild, it turns out that a lot of people, whoever still owned a CD player, were having trouble playing it. And especially some of the older players would just say, hey, there's nothing here because, spoilers, it's clear. But at the same time, like, obviously they wouldn't make it if it couldn't be played, right? So they must have gone through some testing and figured that the playback issues were an acceptable, loss compared to putting the thing out there. So Adrian of Adrian's Digital Basement got one of these CDs and a few CD players and just kind of did like a blind test, like see who could figure out who couldn't. In general, it seems like the newer players did better than the old school ones, but that was not the answer he was looking for, right? He wanted to see why the newer ones and what actually is happening here. And that's where I thought this got kind of interesting, because he opens the players up and he hooks into, you got to find it on your own, but in general, he said a CD player will have a test point for like the actual signal coming from the laser head. And if you put that on the oscilloscope, there's an expected like waveform that you should be seeing. And you can see very clearly when he goes from a professionally done, this one's professionally done too, but a properly done CD. When you go from like a properly done CD to this new Lorde's CD, you can see the signal, the amplitude of the signal is very, very low. The reader is just struggling to get it, and the problem seems to be that because there isn't that reflective layer on the disc, it's just so much of the laser light is just kind of blowing through and isn't getting bounced back. Incidentally, it's the same problem that would keep some players from playing CDRs. And if you don't know what a CDR is, which is entirely possible that you've never dealt with a CDR, if you're listening to this, those are, recordable CDs that didn't always play properly when you burned them because they weren't obviously a factory-made disc. So, just an interesting look into what is now an ancient technology, really, like CD players.
I'm bummed that it doesn't play on everybody's machine, but I do think that's the sort of funny thing you'd read about on Hackaday. Hey, I wonder if we can get one of these, blank CDs to run without the reflective layer. Whoa, let's try. It's a dumb hack, but I don't know if it's a dumb hack I would try to sell hundreds of thousands of.
Well, I think for on one hand, you're probably not meant to play the CD. I have a feeling that, like,
You think it's just an ornament?
yeah, like my brother has hundreds of CDs that he's bought, and not one of them has ever seen a player. He just has them on the wall, and everything's played digitally. I mean that he may have ripped some
Fair
of them,
enough.
but for the most part, he just buys them to have them. And the same thing with I guess anything else you collect, right?
All right, my 3 quick hacks. First up comes from Chronova Engineering, adjustable Allen key after all these years. Chronova, as the name suggests, is into watchmaking, and so it's no surprise that he can make something as delicate as an adjustable Allen wrench. But I learned out of this that the Allen wrench this year is 115 years old. Next up, Ilya Maslenikov, the PC in your Pico. It's maybe not so much of a surprise that you could emulate a 286 in a modern microcontroller, but this emulation is absolutely fantastic. If you go over to the GitHub project, it has not just the core emulated, which you'd expect, but like a whole array of different possible sound cards. It's got the Kovacs speech thing, it's got the sound blasters, it's got the MPU 401, it's got Creative Game Blaster. So like any of the peripherals you need to run your old 286 games. It's got CGA, it's got Hercules graphics card emulated, etc., etc. Whole bunch of funny floppy drives. This isn't just the CPU emulated in this microcontroller. This is the whole damn system. And it's pretty fun if you need a 286 PC for whatever reason. And last up, Electronics Unmessed, the VLF transformation. This is a video about making very low frequency radio antennas and how to do it. There's actually a new video showed up just today that you should go watch. It's part 2 in this series of playing around. Basically, the antennas are just big coils of wire, and he uses a ferrite core and Balun transformer to get the voltages up, but plugs this into a modern SDR or even sound card. Some of these frequencies are so low, and you can look around at what's going on in the crazy low end of the spectrum. It looks like he's picking up submarine transmissions in addition to the radio frequency standards you'd expect to find in this range, and some weather things, and then a whole bunch of just question marks. Down in the 30 to 100 kilohertz range is a whole weird world of radio. And here's how to make an antenna that you can plug in, like I said, either into an SDR or into your sound card straight up and listen to it.
Yeah, I tell you what, if I was picking up submarine transmissions, the last thing I would do is tell the internet about it.
Yeah,
Well, my first quick hack this week is 3D printer. This comes from Ben, who turned an old 3D printer into a robotic camera rig. And if you are not familiar with that is, go watch YouTube. And pretty much any high-end YouTube person where you see these, cool camera angles where like things spinning and it's going over, but that's all, it's not somebody who's really good with the camera, right? It's all a motorized rig of some type that drags the camera across the thing you want to take pictures of and can do all kinds of programmable shots. They are generally expensive, so to be able to make one out of an old 3D printer is really cool, especially as we've covered before. You can get as-is damaged Ender 3s for a song anymore on the secondhand market. So if you're looking to do some cool photography shots in your budding YouTube channel, this might be a project to check out. Next up is reviving a piece of yesterday's tomorrow. This one comes from Sir68K, and it is a project that creates a new drop-in replacement display for a specific model of Sony's mini disc player. These devices are now pushing 20 years old, and the early OLED displays in them are starting to fail. Original replacement parts are obviously impossible to get, so this project takes a modern display and adapts it into a drop-in replacement, but not necessarily an easy replacement. There's still some very fine work that needs to be done, but in the end, your mini disc player will play again, and as an added bonus, the screen looks better than the original one did because it's 20 years newer. And finally, Silent Speak and Spell gets its voice back. This is just, I'm a sucker for a repair video, a repair project, and this one's from Kevin. Found the old school, not the new recreation, but the old school proper Speak and Spell that it looked like somebody had plugged the wrong AC adapter into and released the critical magic smoke. So he takes a look at the board and looks at some of the documentation out there because, of course, people have documented the Speak and Spell and put reverse engineered schematics and stuff out there. Ultimately figures out what's wrong with it and gets it up and running again for a new generation to enjoy, which is always cool.
All right, now it's time for our can't miss articles. These are long form pieces written by our fantastic Hackaday writing staff. This week I got Maya Pasha's The Terminal Demise of Consumer Electronics Through Subscription Services. And terminal here is a double entendre. This is the second piece in a kind of rant series Maya has been doing about/against subscription services, anti-consumer practices, everything in the cloud, etc., etc. The first one, she kind of focused on how modern devices have become blander and blander looking because all of the things they used to do has been kind of outsourced to the screen. In this one, she's taking that kind of a step further and saying the device now just a terminal for a service in the cloud because everything just serves this one purpose of being a window into a cloud service. Like there's nothing at all you can do with any of them. And so, they're streamlining everything out. Everything's kind of as a service and delivered to you. And if the last article was about how this is kind of making the design of objects boring, this one's a lot more about how it's making the devices themselves less and less powerful, less useful to us. They're just more and more minimalist because they don't need to do anything anymore. That's the terminal joke here. Al Williams has been in the computer game long enough that he's seen it go through a whole bunch of these cycles. From back in the super old days when you had a mainframe, the only way you could log into it was with, so-called dumb terminals. And then we got the microcomputer revolution where everybody got their own computer. And then it was thin clients and everything was back to being central plus a terminal again. I guess then it was a second wave of home computers. And then it's everything's in the cloud. And now it's on the edge. And, we just keep going back and forth between these. And my hope for Maya's complaint is that a lot of this may just be one of these temporarily long swings between a time where everything gets put in the cloud and the devices all become terminals versus a time when we finally get our computers back. I think only time will tell, and we'll have to see. On the other hand, things like the smartphone as a do-it-yourself home server project we saw even just today kind of point out that maybe it isn't quite as drastic as Maya's worried about here, as long as you're willing to granted, this guy's using his phone as a home server. It's not a phone anymore. And in fact, he's deliberately buying them with broken screens because he doesn't need that part to work. So, you do have to kind of nuke the thing's old purpose to make it live this new purpose. But maybe that's our way out.
Like I said, time will tell, I guess. But it is interesting to kind of reflect on the cyclic nature of computing, I suppose, right? Because like you said, there was a time when there was a there was a big computer somewhere, and you had your little dumb terminal, and that's how you accessed it. And then computers became cheap, and everybody got one at home, and you didn't need the big computer down the hall. Except now we've kind of returned to that time, and instead of the big computer being down the hall, now it's somewhere else in the world, and you're accessing it for more and more your day-to-day use. But now, we stream all of our content, and you're even starting to see push towards streaming games over the internet as you get high enough bandwidth and low latency. You have these services, Microsoft, Nvidia. I think everybody has some toe in the water where you're sending signals to a server somewhere that has the graphical oomph to play these high-end games, and they send the resulting video stream back to your phone or whatever thing isn't strong enough to play the game in the first place. Just like you were watching Netflix, it's like an interactive video stream. People seem to like that. So it's going to be a whole nother era where, you'll be less and less ownership of the actual media, and you're just streaming it and renting it from, a megacorp. Some of it is just the nature of convenience, right? Like there's no arguing stuff is more convenient now. Like, you can make the case that, the devices are more boring and everything's kind of samey, but, being able to play a movie wherever you are on your pocket computer is pretty convenient compared to being like, well, let me go find the disc and let me put it in, and oh no, the disc is clear because somebody wanted to make a statement, so I can't play the disc. I need to get a new player. There's something to be said. Like, things are a lot more convenient, and I gotta say, we are creatures of convenience, and I think as the newer generations come up with this kind of stuff, it's very hard to go back.
Yeah.
I got a 15-year-old and a 7-year-old, and for both of their lives, like, movies were just a thing you picked on the screen and hit play on. You know what I mean?
Right, sure.
Like, they have no concept of, like, I have to go get a disc or God forbid, a tape. You know what I mean? Like, it just never was a thing for them. Stuff was on your terms, and once you've grown up with that, you get used to it. I mean, I remember, like, the first time my daughter was at her grandparents' house, and, they're just watching linear cable, and, like, a commercial came on, and she was like, what is this? Like, why is my show
making
stopped?
me nervous. Why am
fast forward through this. I don't like it. And they're like, no, honey, you have to sit through it. And it was it was a very, weird moment for someone who'd never experienced stuff that wasn't on their immediate terms, right? And I think that's kind of how we're all getting, for better or for worse.
Yeah, you brought up your kids wrong. We at least have some DVDs and CDs. DVDs and Blu-rays kicking around the house. Maya takes this, like, intentionally orthogonal view on some of this. Like, she comes at it funny. She starts off with, like she's a little bit of a Martian to this whole scene. In the burgeoning consumer electronics world of the 1950s, everyone was into streaming audio-visual content. And, of course, she means the radio and the TV, right? Which... is that streaming? Is it streaming if you don't get to pick the time? But it was streaming. Like, it was literally streaming. It was a centralized thing, and your TV was just the dumb receiver of everything, right? In the same way that, like, the computer terminal is, back then was just the dumb computer terminal. And then we moved on to things that had the smarts to play the DVD or the Blu-ray or, the video game console. And then we moved on to things that couldn't do that again. And I don't know if it's gonna bounce back or not. When the computer became the gaming computer and we had, all of these, like, high-powered graphics cards that ate up megawatts, I don't see the gaming cell phone taking place anytime soon. Like, just the battery constraint is going to prevent that from ever doing high power number crunching on the cell phone. So maybe you're right. Maybe it is just going to stay in the cloud. Maybe there will be no bounce back on that one.
So much of our stuff is running in the cloud off of another machine. But I think the difference now is that the dumb terminal is way too smart.
Right?
Like, if I'm pulling all my stuff from remote sources anyway, why does my phone have to have 12 processors and 6 gigs of RAM? You know, like, I think if there was a revolution of like cheap, low powered, super efficient mobile devices, like if I, you know, if my phone would last a week on a charge because all it's doing is pulling down stuff from the real number cruncher over the internet, like that would be great. But
Oh, hell yeah.
somehow we got the worst of both worlds. You know, we have the expensive, energy-hungry local devices, and we got the expensive, energy-hungry remote devices, and they're connected with a expensive, energy-hungry wireless medium. You know, I think we've learned the wrong lesson in some ways. Well, my can't miss is Instant Macro Pad, just add QMK. This is from Al Williams, and this is something that I'm really glad he did. I have been personally interested in this, and I think probably a growing segment of the readership is interested in it, judging by how many custom keyboards and macro pads and stuff come in. Like, this is now certainly a hot topic, you know, building your own input devices. And a lot of that is due to the fact that there are these projects like QMK, which is this turnkey firmware to make custom whatever you want input gadgets. All you gotta do is bring the hardware and configure it, and that's what Al does in this one. And he threatened to do this one for a while, and I'm glad that he finally had the time to make it happen, because it does really show how the only limit is honestly your imagination right now for how you want to interact with the computer. In this case, you know, he grabs an off-the-shelf RP20 board with some buttons and a screen, but, you know, the hardware is not really important. You know, you just need a modern microcontroller with buttons or encoders or whatever. And then, you know, he goes through the process of pulling QMK down from Git and configuring it and building it. And that's really kind of where the meat of this is, like, what's the actual process of, you know, bringing the latest down. And, you know, it's not exactly, you know, 1, 2, 3 easy, but compared to having to write the firmware yourself, it is certainly a revolution in that respect. Pull this down, you know, make a directory for your new gadget, edit 3-4 files with some pertinent info, and there you go. You know, have a USB gadget that does exactly what you want on your own terms. And that on your own terms thing is something that comes up a lot on Hackaday, because I think that a lot of people, at least in our circles, like that idea of having full control over something. And even if you only ever dealt with the configuration that first time, like, you know, there's probably not a lot of tweaking that necessarily has to happen for a macro pad, right? Like, once you get it, you get it. But the idea that you could go back in and change the configuration and add something, and it really does make it your own. And I guess this is kind of, you know, I didn't intentionally do that, but it's kind of the counterpart to what we were just talking about with Maya's article, where the stuff you buy is kind of like this black box, and it does what they tell you it does. Whereas this is, you know, hardware that you tell it what to do. And that is refreshing in the modern era that you can do that. And we're even starting to see like commercial keyboards. We talked about that, I think, when Al was talking about doing this. There are now commercial keyboards that you can buy that already have this open source software on it. There are other, you know, QMK is one of them. There are other kind of spin-offs and forks and stuff. So it might not exactly be like this, but the concept is the same. You know, it's an open source community developed firmware that, if I was making keyboards, why wouldn't I use it, right? If I was in the business of making, why not take advantage of what's already out there and popular? You know, I'd love to see more consumer devices go that way.
I think you said it in the very beginning. QMK is the software that makes taking a microcontroller and hooking it up to like a bunch of switches and some other devices and turning that into a peripheral for your desktop or laptop or cyberdeck. This is the software that makes doing that stupid easy. And there's a whole bunch of configuration software for it that makes doing that part easy. I'm typing to you at the moment with a keyboard I made myself using QMK. It's no surprise either. There are other software spin-offs of it And actually, I guess QMK came off of TMK or something. And now there's a ZMK, which is kind of if you want to do this, but in Bluetooth and with, I think, Python for the configuration files. One thing that's really annoying about QMK for some people is that to set it up for your particular device, you do have to edit some C header files, and they've got a bunch of macros you have to look up. And some of the good news is some of the online configurator tools will do this for you. Al doesn't use it because, well, he's Al.
Yeah, right.
But you don't want to have to see, KB underscore volume underscore up. You don't want to have to type that. I just want it to do the volume up command attached to this button or this knob or whatever. So there are easier ways to do it, but Al's way is also kind of the lowest level, most general, and guaranteed to work way. So in that sense, it's a really nice walkthrough of what somebody who's used to programming in C would do if they approached QMK, and I think that's pretty awesome too. To be fair, that's the way I did my keyboard too. I did it all by hand because it was in the long ago past before they had any of the nice web tools to do it.
Yes, I get you. But yeah. I do think there's always benefit, I think, from taking things from like the lowest possible.
Oh, hell yeah.
Maybe on your second board, you don't you don't do it from scratch like this, but I think it's good to
or maybe vice versa. Maybe start off.
Well, that's true. Yeah, that's a good point.
If you're starting off, just go type into your web search QMK configurator and get it to configure the dumb H files for you. And then your next one, if you need to play with it and expand it. And actually, Al's going to do a second in this series soon where he gets into the weeds and he gets into debugging it and writing macros for it and stuff like that. And that is where, a little more understanding of it is actually useful. So you'll see that next time around.
There was always the thing like, should you build a 3D printer from a kit or buy it turnkey, right?
Right.
And I was always very big on, if there's a kit, take the kit one, because at some point this thing is going to clog or it's going to make a weird noise and you're going to be like, well, what the hell is that? And it helps if you've pieced the whole thing together, so you'll know, you have a picture in your mind like, oh, okay, like that's probably that thing that's not working right. Whereas if you just buy it as an off the shelf turnkey thing, you lose that kind of insight. And insight is always good when things go wrong. I'll put it that way. In a perfect world, maybe you don't have to worry about it, but we don't live there quite yet. And if you're going to need to fix something or figure out why it's not doing the thing you wanted to do, understanding how it works from a bare bones approach is always a nice leg up.
I do agree with that general philosophy. But there's a reason there's streamlining software tooling for basically everything out there. And it's because software sucks. People write software to be more complicated than it needs to be. And then they write layers over that to make it less complicated. And then they write layers over that to make it less complicated. I'm not going to insist you do it by hand. Go get QMK configurator. It'll do you well. Well, that wraps it up for this week's Hackaday Podcast. Thanks very much for listening. If you see anything you want us to cover, drop us a line, tips@hackaday.com. And if you want to follow the links in this show or any show, head on over to hackaday.com/podcast. And until next week,
keep on hacking. Just in case.
Super stretch. Very small portable gamma ray spectrometer. Scintillaction detector.
There's a reason I'm staring at the fire.
No, spell.
Oh, cool. It's fixed. It's a wonder they didn't raise up a whole generation of kids with a speech impediment listening to that thing.
This is blah, 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 blah. I think that's it. Okay, maybe not.